we will see in which cases these shortcut techniques can be applied, because everywhere these techniques cannot be applied. So if we have connected body system, suppose we have pulley system, okay, so all the objects, all the parts of the connected system must have common magnitude of acceleration. If they do not have common magnitude of acceleration, you cannot apply. Okay, so first we will write all parts of connected body, all parts of pulley system must have same magnitude of acceleration. Same magnitude only required, only magnitude, no direction is not compulsory. Direction may not be same. Then acceleration of the system can be given by net pulling force divided by total moving masses. Okay, so what does it mean? So let us see what does it mean. Okay, suppose we have this pulley system, one mass is here, another mass is here. Okay, so this is M2 and this is M1. So net pulling, first we will see whether we can apply or not. So if this is coming down with acceleration A, this will go up with acceleration. So they have common magnitude of acceleration. The acceleration direction is only different, but magnitude is common. So in this way, in this case, we can apply. So net pulling force. What is net pulling force? So this object is trying to pull this whole system. Means this M2 is trying to move this object. So M2G is the pulling force, but M1G is opposing force. So net pulling force is M2G minus M1G. M2G is trying to give the acceleration to the system, and M1G is trying to stop it. So M2G minus M1G divided by total moving masses. So M1 plus M2. So this will be how much? G into M2 minus M1 divided by M1 plus M2. Okay, so in this way we can do. So this is just one example. I am going to give the another example. This is one, and there is next example. Suppose we have an incline like this. This is theta. An object is placed over it, and this is suppose capital Mg, and this is suppose small m. Okay, capital M and small m. So what will be acceleration of the system? So again you can see, if this is going down with acceleration A, this will go up with acceleration. So same magnitude, acceleration at same magnitude. So we can apply the shortcut technique. So shortcut technique, net pulling force. So this is the object whose weight is trying to pull the whole system. So Mg is trying to pull, and then small mg is there, but a small mg is not trying to pull completely due to its weight, only the component of this small mg. So component of small mg along the motion is mg sin theta. The component of small mg along the motion is mg sin theta. So we can write capital Mg minus small mg sin theta. This is the net pulling force divided by total moving masses. So in this way we can find. So this will be the acceleration of the second object. Okay. Similarly, we can take some examples from friction. So as we saw the last example we can take, suppose we have one object here, and they both are hanging, okay, like this. So this mass is 1 kg, this mass is 1 kg, this is 0.5 kg, and here friction is 0.5 and 0.5, sorry, 0.2 and 0.2 Newton. 0.2, sorry, 0.2 Newton, not Newton, but 0.2. Friction coefficient is 0.2. So here also, if this is accelerated with A, this will accelerate with A, this will also accelerate with A. So they have common magnitude of acceleration. If they have common magnitude of acceleration, then we can apply the formula. So formula will be what? The net pulling force. So net pulling force of 5 kg. 5 kg is equivalent to what? 5 Newton. 5 Newton is the pulling force. And then what are the opposing forces? So friction here and friction here. So how much will be friction? You can see 1 kg means normal will be how much? The normal here will be 10 Newton. 1 kg weight means 10 Newton the normal. And the friction here will be 0.2 into normal. So that is 2 Newton. Similarly here also the friction is 2 Newton. Okay, so if you write F1 and F2, we can write F1 and F2 are as opposing forces. So net pulling force is this much and total moving masses. So 1 kg plus 0.5 kg. So these are the total moving masses. So 5 minus 2 divided by 2.5. So if you solve it, 1 by 2.5. Okay, so that we are going to get 2 by 5 meter per second square, which is 0.4 meter per second square. So in this way we can solve this question. Okay, so these are the application, and I will also give you an example where this cannot be applied. So where it cannot be applied, if you have something like this, if you have suppose you have an example. This kind of system. Okay, so in this case the acceleration of two objects are not same. If this one is going up with acceleration a, the second object will go down with acceleration 2a. So you can see magnitude of accelerations are different. So if these two are different, we cannot apply the this shortcut method. We cannot apply the shortcut method in this last case. Okay, so in objective questions this is useful. The method is useful in objective questions.